Hi everybody. I wanted to give you a rather more complicated implicant chart example. Here what I've done is I've started us out with a present state next state table, already encoding the diagram, which gets rather involved if you write it out, so I just wrote out the table, skipping a step. And what I'll do on the horizontal axis is I'll start with A and work my way up to F. A, B, C, D, E, and F, skipping the last letter G, and then proceeding to do a lower triangular matrix. And now looking for trivial reductions. First I want to find out if there are any outputs which are different from other outputs, and I can see that A must be different from D because the outputs are different. So I go from A to D and put in an X. Similarly, B must be different from D, and C must be different from D. D must be different from E. D must also be different from F and G, all because the outputs are different. And so these trivial reductions in here give us a mechanism by which we can proceed to find pairwise reductions. Let's take a look. From A to B, we see A and B are equivalent if A and B are equivalent, and they're also equivalent if C is equivalent to C. The outputs are the same, therefore they're equivalent. And so now we can write A is equivalent to B. That'll give us a reduction. Let's look at A and C. We see A and C are equivalent if B is equivalent to D. And we also see A and C are equivalent if C is equivalent to E. So let's take a look at BD. Well, we see they're not equivalent, so we can remove it from consideration. They can't be equivalent. A cannot be equivalent to C. Let's look at A and E. A can be related to E using AB. So we look at AB, that's equivalent. A and E are equivalent if C and F are equivalent. So let's look at C and F. Well, we don't know about CF, so let's put that in here. And now let's chase down CF since we seem to depend on it. So C and F are equivalent if B and D are equivalent. We know they're not. Therefore, this is not equivalent because B and D are not equivalent, which means CF is not equivalent. That's CE. CF is not equivalent. Let's look at CF again. CF is BD. BD is not equivalent, so we can remove it. What about CE? CE is equal to AD. AD is not equivalent, so we were right to put that in there. CF is not equivalent, so we can remove it. Let's take a look at AF. A to F is B to B, that's good. And CG, let's look at CG. CG, we don't know anything about it, so let's look it up. CG is equivalent if A is equal to D. We know A is not equal to D, therefore this is not equal to D, and that's not equal. AF is not equal. So there we have some more progress. How about AG? A and G is equivalent if A equals B. We know it is. What about C and E? Well, if we look up CE, we see it's not equivalent, so we can remove that from consideration. Let's look up BC. BC is AD. AD is not equivalent, so BC is not equivalent. Let's look up EB. EB, or BE if you like. So BE is going to be AA, that's good. And then CF, and we know CF is right out, so we can remove that. How about BF? So from B to F, we look at AB. AB is good. We look at CG. CG is not. So that is removed. How about BG? So we look up BG. We're looking at all combinations. A and A, they're equal. C and E, they're not equal. So we can remove that. Let's look at FE, or EF if you like. AB, that's equivalent. FG, well now let's see, FG we don't know. So let's put that FG over in here and take a look at FG. So FG is AB. AB is equivalent. GE, here's GE. We don't know anything about GE. So let's look up GE. So that's AA, they're equivalent. FE, what about FE? Well, FE we don't know. FE, so they're all interrelated. They're all equivalent to each other. So what does that mean? Well, it means that G is equivalent to E, which is equivalent to F. And that's very nice. So our reduction says A equals B, which means we can remove B, and anywhere we see B, we can write in an A. So that's pretty cool. We also say that G equals E equals F. So let's remove G, and everywhere we see a G, we're going to write in an E. But before we go there, we can also remove F. That's pretty cool too. So now we're down to E, and anywhere that makes reference to G, we can replace it with an E. Anywhere we see a reference to F, we can replace that with an E as well. And that gives us a much smaller state machine. So we started out with 1, 2, 3, 4, 5, 6, 7 states. We ended up with 1, 2, 3, 4 states. A much smaller machine, much cheaper to implement. Thank you.